I'm ready when you are.
Okay, so it's 3 over 7x plus 7 equals 4 over x plus 1 minus 5 over 7.
Like here?
Yeah.
Minus 5 over 7? Good, very good.
Which number is this?
Which number is this?
It was on my math lab.
Okay. Do you remember as
It was on the
1.2? Okay, very good. So first of all, I asked myself, what type of equation is it? Obviously, it's an equation because it has the left-hand side and it has the right-hand side. So it must be an equation. What do I do now?
Make the denominator the same.
True. So what type is it? Well, it has a ratio and it has x in the denominator. What can it be? Rational. It's a rational equation, right? Yes, everyone? Okay, very good. So it's a rational equation. So from here, I will have to factor out what? Very good. And I have very good, awesome. So then I know that x cannot be, for sure. Very good. There is no need to write anything else for this one because it's the same. If you're using my method, then I will do this. If you have a different method, use your method. Is this okay so far? Okay. So after I identify that it's a rational equation, then I state the restriction so that all denominators exist. The next step number 3, I move everything to one side, and if I forget the equal symbol and 0, I change the equation into an expression I will never solve. So this is very important. Okay, next, what do? I find the least common denominator. Look what I draw. A long fraction line, I copy the equal symbol and 0. Because I may forget to write the equal symbol and 0, and then the whole thing collapses. I will not solve for x. Good. So then the least common denominator is? Very good. The only 2 factors I see in the problem. I see 7 as a factor, and I see x plus 1 as a factor, so both factors have to be in the least common denominator. Nothing else is required here. Good. So now I have to ask myself, fine. If I multiply the denominator by whatever, I have to multiply the numerator by the same quantity. Otherwise, I change the problem. So what am I multiplying 3 by? None. Yes, nothing meaning 1. You don't have to write anything, really. So what do I multiply the top of the second one by?
7.
And the last one by?
X plus 1.
Very good. Now I have to be careful and write the numerator after I distribute whatever I need to distribute. So, yes.
3 minus 28. And then 5x plus 1. 1, 5. Oh, 5.
Good. So we distribute 5 to x plus 1. Is that clear? Good. So next we do what? Very good. And put everything in descending order. I have a 5x. This is a positive 8. And this is negative 28. So this must be negative 20 over 7 times x plus 1 equals 0 over 1. Agreed so far? And now the next step would be, what do you think? Cross multiply. That's why I put this. Just as a reminder, like I put this. All these are my reminders. Hey, you multiply the denominator, you have to do the same thing to the top. So that's why I put the 1 to remind me to cross multiply. So this is 5x minus 20, which is multiplied by 1, must equal? Very good. So then I get that x equals 4. My first thought is this. Since 4 is not on that list, I'm fine. Is this better?
Yeah, it is, but I just wrote 3 problems down and now I'm confused about 32. But it's okay.
Do you have another one? Yes.
Okay.
Yes,
So
please.
read
Hold on
I
one
have a
second.
question about this one.
Yes.
When you multiply the numerator,
Yes.
where did you get those numbers?
Okay. So I'm asking myself, what did I multiply the denominator by to get this? And the answer is 1. What did I multiply the denominator by to get this? And the answer is 7. What did I multiply this denominator by to get this one? And the answer is x plus 1. Better? Perfect. Other questions here on this one before we move on? Awesome. Very good. Yes, let's look at the next one.
It's just another math.
That's fine.
So it's 3 over x plus 4 equals 2 over 3x plus 25 over 6.
Let me read it back to you just to make sure that we copied correctly. 3 over x plus 4 equals 2 over 3x plus 25 over 6. Perfect. Very good. There is nothing we need to factor in the denominator, but we immediately will write that x does not equal 0. Very good. Awesome. Here there is nothing else. It's 3 times x. Still the same thing, the same restriction. Because 3 times x not equals 0, I always simplify dividing by 3 and I get the same thing. Now I will be moving everything to one side. 3 over x plus 4 over 1 minus, I will erase that, minus equals 0. Now I'm asking myself, what is the least common denominator?
Would it be 6?
Say it again.
So would it be 6?
Okay, how many different factors we have here? We have x, we have 1, we have 3, we have x, but we also have 2 times 3. So how many different factors? One more time. 1, just consider 1. So 3 is a factor, 2 is a factor, and x is a factor. So what is the least common denominator? So for example, let's suppose I make the mistake and write 6. I'm stuck. Here's why I'm stuck. Because the question is now, x times what is 6? 6x. No, 6 over x. So x times what is 6, I have no answer. So then 6 is not the correct least common denominator. I have to be able to say x times blah is 6. I can't. So this is not the least common denominator. So what is the least common denominator then? 6x. Of course, right? We have x as a factor, we have 3 as a factor, and we have 2 as a factor. All different factors must be in the LCD, otherwise I don't have answers for the top. I know that I messed up with on the least common denominator when I don't have an answer for one of the tops. So here's my question now. If I find answers for all tops, I'm fine. X times what is 6x?
6.
1 times what is 6x? 3x times what is 6x? And 6 times what is 6x? So I know that this is the correct least common denominator. I found answers for all tops. And now I'm ready to write the numerator. Ready?
18. 24x. 4. Negative 25x.
That's it. 6 times 3, 6x times 4, minus 2 times 2, minus x times 25. Is this clear? All steps? Perfect. So now I combine like terms. Negative 25 with 24 is negative x, and 18 minus 4 is positive 14, divided by 6x, and this is my reminder not to forget what I need to do next. So when I cross multiply, I get a negative x plus 14 is 0, linear equation, x equals 14. Very good problem. It was very useful. We learned something from it. Very good. Thank you. Other questions for me? Anything else before we go back to inequalities? Anything? I hope you keep up with 1.1, 1.2, 1.5 to 1.6, right? Yes, please.
Can you do 33 on page 185?
30 what?
33.
Yes. X minus 4 to 3 halves equals 33. 27. So this is 33 on 185. What type of equation is it? It's not polynomial. Fractional exponent, awesome, yes, thank you. So I recommend, let's clear the denominator first and then we'll worry about the numerator. And in these problems, we'll see what we come up with, but in these problems, most probably they want just a real solution. Okay? Which is okay, but they should ask all proposed solutions, but they're asking for the real solutions, actually. Okay, so how do I eliminate this denominator? I raise. Yes. In other words, if you want, you're saying that you multiply that fraction by 2. Correct, correct. I agree. So remember, I raised both sides to power 2. What do I have to do for sure at the end? Check. Yeah, yeah. Okay, so then what is left on the left-hand side? Very good. And this is 27 squared. Thank you very much. And at this point, as I said, I truly believe, because otherwise, this is now polynomial. It should have 3 solutions. But I think they're only asking for the real solution. So at this point, we're just going to take the cube root from both sides. And we have x minus 4 equals the cube root of 729. Let me show you. I'd like to show you the way I like to determine the cube root. But it's up to you. And I apologize for not being prepared. I'm prepared with everything else, but I'm not prepared with this. Sorry for the wait. Okay, so you have several ways of determining the cube root. Here's one way in math. Here's your cube root. So you press 4, and you put 729. And you determine and you get 9. Here's what I like. What is the cube root? What power is the cube root? And you have to give me a fraction.
That's 1 over 3.
Exactly. This is what I prefer. I don't like to go into math, but this is me. I put 729, close the parenthesis, power, in parentheses, 1 divided by 3. You can say the other one is much easier. Use the one you like. It doesn't matter. Okay? So we get 9. So this is 9, and then from here, x equals 13.
Oh, it wouldn't be x minus 4 equals negative 9, then x minus 4 equals 9.
Very good. Awesome question. The cube root has only one real solution.
Okay, so
Not
like
plus or minus.
You would do that if it was a plus, like a square.
Square. Yes. Very good question. Thank you.
Or anything equal.
Yes, but it depends. It depends because when you get the square root of x to the 4th, depending on the problem. But yes, I would say yes.
I mean, like, whatever the power is on this even, you're going to have to always have plus or minus.
Correct. Correct. Yes, please.
So the first step is to raise both sides to the
Second power to eliminate the denominator. Because if the denominator is something over 2, so if you raise both sides to 2 over 1, then you eliminate the denominator.
Okay, and then the second step is
To eliminate power 3, which uses the inverse operation, which is power 1/3, or the cube root.
So what if the denominator was 2?
Whatever it is, then you have to raise to that power. If the denominator is 5, you raise both sides to the 5th power.
Okay.
Because whatever over 5 times 5 over 1
Right.
will eliminate the fraction.
Okay.
Whatever the denominator is, that's what you raise both sides to. Very good. Next question. Anything else? Awesome. Yes?
Homework.
Yes?
On the homework, 101 on page 186.
Yes? So you said was 101.
Yes.
Okay, solve for v. Awesome. So we have r equals the square root of 3v over pi h. Very good. Now you can say, wait a minute, what happens here? I see 3 variables, right? Pi is not a variable, pi is a number, right? But I see v, I see h, and I see r. But we're specifically told the variable to solve for. So we have to treat everything else as if they are numbers. So V is what they want. So in other words, this is a number, this is a number, a number, and a number. And V is here, this is our variable. Now I ask myself, based on the variable, what type of equation is it?
Radical.
Of course, it's a radical equation. And the index is 2. It's a square root, right? So what do I do to both sides to eliminate what power? Exactly. Square root is power 1 over 2. So what will I do to both sides to eliminate the square root? Very good. So then I have r squared. What is left on the right-hand side? Say, that's it. 3v over pi h. Remember, we are solving for this and only for this. You can do it in 2 steps. You will eliminate what first if you want to do it in 2 steps? Pi h, correct. So I will eliminate this, multiplying both sides by it, and then the second step would be, or you can say I want to take care of both or everything at once. Then you will multiply both sides by pi h over 3, if that's what you want. And then you're done. Why? Look what happens. Pi would go away, 3 would go away, h would go away. So what is left on the right-hand side? Exactly what I want to solve for. And here I just have to rearrange it. Pi h r squared over 3, and I'm done. Very good problem. Anything else?
What kind of problem did you say this was?
A radical equation. Was a radical equation because the variable we were asked for, to solve for, was under the square root. That's why it's a radical equation. Good. Anything else? Anything else, please?
Would there be an instance where you don't put the r squared in the numerator when you bring the fraction over?
Because it's not something over, it has to be in the numerator. So you could leave it as is, pi h over 3 times r squared. Or say that this is over 1, pi h r squared over 3 times 1, and you write it like this. Both of them are acceptable. Both of them are good. Very good question. Don't tell the other 137s that I have that you're the best group. Okay, very good. Well done, guys. Anything else? Anything else? Okay, so let's continue then with, oh, I just recorded that. I should have not said it. Never mind. Okay, good. So, okay, I wanted to talk about the set builder notation because you are going to, yeah, see, I can't say anything. So let's talk about the set builder notation. Because you will encounter this in my math lab, I don't care for it. I will not ask you for it. So, for example, when we have, let's say, this inequality, and we are asked to write the interval notation, this is very clear, bracket at -1, comma 3 with a parenthesis, and it's done. But the set builder notation is this. Uses braces. I have to write x. I have to write or draw a vertical bar, which means or stands for such that, or also having the property. Having the property. So, in other words, the solution to this compound inequality is nothing else but all values of x such that, or having the property, -1 less than or equal to x less than 3. So what's the difference between this and this? There's none. So I prefer the interval notation, and you will see later in this course why the interval notation is more important than the set builder notation. So this lists a property of x. So the solutions to these are nothing else but all values of x such that this happens to x, and you close the brace. But my math lab will ask you to write that, please.
Is interval notation when you use like negative infinity to?
Yes,
Okay.
yes, we're gonna have more inequalities right now, and you'll see that, yes.
So we could do a set builder notation for the like last problem we did in class. Like the one
Yes.
that we went over.
Yes,
Okay.
yes, we can. However, I will ask you for the interval notation, not for the
Okay.
set builder notation. But I
So
want
that's
you
just
to
another way that we might see.
exactly. The math lab will ask you to write this, not this. Sometimes, I mean, both, but sometimes they will ask you to write that. Yeah, so that's why I want you to see it here first. Okay. So we're back to inequalities 1.7. So let's look at another one. Let's say problem 45 on page 203. And that is x minus 4 over 6. And that is greater than or equal to x minus 2 over 9 plus 5 over 18. Okay, what type of inequality is this? And no, you cannot say rational. Why you cannot say rational? Because there is no... Exactly. You cannot say rational because there is no variable in the denominator. They're only numbers. Numbers are not variables. And this is 9, I'm sorry, let me... Okay? So now you're going to say, okay, this is a linear inequality, clear. However, I don't like fractions. Don't be afraid of fractions. In a blink, we will get rid of them. How? Exactly. What is the least common denominator of 6, 9, and 18? So, okay, let's discuss this. This is very important, very important, very important. Greatest common factor is one thing, and the least common denominator is a totally different thing. So when we are finding the least common denominator, we are not interested in finding the greatest common factor. Now let me give you 2 examples so we understand what this means. So if I'm given 2x squared minus 4x, the greatest common factor is what is present in both at the highest possible power. Well, 2 is present in both and x is present in both. And then the answer inside, or the simplified form inside, is 2x, x minus 2. So 2x times x is this. 2x times 2 is this. Times negative 2 is negative 4x. So this is one thing, the greatest common factor, what I can pull out from all of them, right? If you remember the factoring document that I created. The least common denominator, or the least common multiple, let me write that too, denominator or multiple, is something totally different. Is the smallest, I shouldn't say the smallest, the largest number that goes into all 3 in this case. That I can, such that the, forgive it, the smallest number that is divisible by all 3. Not the number that goes into all 3, the largest number that goes into 3, 6, 9, and 18, but the smallest number that I can divide all 3 by, and I get a number. So if I say 3 I cannot divide by 6 and get a number. 3 I cannot divide by 9 and get a number. I need the smallest number that is divisible by 6, divisible by 9, and divisible by 18, so I can get the adjustments for the top. So 6, 9, and 18. I need a number such that this number divided by 6 is a number. This number divided by 9 is another number. And this number divided by 18 is another number.
18.
18. See the difference? So this has to be the smallest number that is divisible by all three. This one is the largest number, the greatest common factor, the largest number that goes into both, that I can divide both by, that both are divisible by if you want. So in this case, it must be 18. So we have to multiply both sides by 18. Because they're all fractions, I recommend writing it like this. Because it's easier to see how to simplify. Never multiply and then simplify. You're getting in trouble. Always simplify and then multiply. So for example, I'm not going to distribute 18 and then at the end try to figure out how to divide by 6. No. I'm going to simplify first and get a 3. And that's what I have to distribute to x minus 4. I'm going to simplify and I get a 2. And that's what I'm going to distribute and these two go away. So always simplify before you multiply. So 6 divided by 6 is 1. 18 divided by 6 is 3. 9 divided by 9 is 1. 18 divided by 9 is 2. And 18 and 18. Now, in a blink, this will become more human. But please understand the difference between these two concepts. The greatest common factor and the least common denominator. That's why we don't say the greatest common denominator. We say the least common denominator. That's why we don't say the least common factor. We say the greatest, the biggest that goes into both. Does it make sense? Okay. Thank you, Grandma. I love you. I know I sound like you. Okay, so then what do? 3 quantity, let's write it like this. Greater than or equal to, just for everyone to see, what? 2x minus 2 indeed, and then plus? That's it. Do we all agree with this step? Do we all see it? Do you have any questions for me? Is this okay, everyone? Perfect. And now this is trivial from this point on. I shouldn't say trivial, but it's not difficult. Did I pass an hour? No, okay, good. So now I will distribute 3x minus 12 greater than or equal to 2x minus 4 plus 5. Do you agree with this step?
Yes.
Okay, perfect. What do I do next? It is? Yes, awesome, thank you. Combine these two and then decide what to move where. So 3x minus 12 greater than or equal to 2x plus 1.
I would move the 12 to the right.
I would do that too, I agree. I think it's easier if I keep the variable on the left-hand side no matter what. It's just a habit, basically. So 3x minus 12 greater than or equal to 2x plus 1. And yes, I will move this. Remember when we say we move, all we do is change the sign. I have a 3x, but I'm bringing what? I'm bringing a negative 2x. So 3x minus 2x is? Good. And then when I'm bringing negative 12 to the other side, I have this. Now, how do I write the interval notation? That's very important.
X equals bracket 13 comma infinite.
Very good. Awesome. So let me write it. First of all, let me show you on the real line. There is no need to graph this, but just for you, since this is somewhere I have here 13, greater than or equal to 13 means this. And this is the interval notation. I use the bracket because of the equal symbol. I would have used the parenthesis if I did not have the equal symbol. So then I have x in the interval 13 to infinity. Very good. Do you think we need more linear inequalities? Please.
When do you know to switch the inequality sign?
Very good. Awesome. Perfect question. Yes, let me explain. Is 2 less than 10?
Yes.
Let's decide to, for whatever reason, divide both sides by negative 2. 2 divided by negative 2 is? 10 divided by negative 2 is? Now the question is, can I still keep this? Can I still keep this?
No.
No, that's the reason why we have to switch. So every time we multiply or divide both sides of an inequality by a negative number, we have to switch the inequality symbol because it will not be true anymore. -1 is not less than -5. -5 is less than -1. Very good point. Thank you. Do we need more examples with this, or can we move on to absolute value inequalities? Okay, that's the next and the last type of here right now, absolute value inequalities. So I'm going to start with a very simple example. We are going to discuss it, and then we'll apply the same concept in more difficult situations. Okay? So these are absolute value inequalities. If you remember, we said, correct me if I didn't say it, the absolute value is not a grouping symbol. There is nothing I can do. If I have a 2 in front, I cannot distribute it in here. If I have a 3, I cannot take it outside. However, there are some properties, but we don't discuss those properties in this class. So what does this say to me? Before that, what does the absolute value of 5 mean? It means the distance between 0 and 5. So the absolute value is the distance. Okay, now, what does this say to me? It says this. Find numbers x whose distance from 0 is less than 3 units. So there are 2 numbers 3 units away from 0. Which numbers are they? 3 units away. -3 and? Correct. So where will I find numbers whose distance from 0 is less than 3?
2.9 stretching and then -2.9.
Correct. How do I write that? And I'm showing you how to write it.
It's the parentheses 1 to 3.
Not the interval notation, the inequality first.
It's -3 less than x less than 3.
So this translates into -3 less than 3. Oh, let me put the equal symbol there. It doesn't matter. If I have the equal symbol here, I have to put it here. If I don't have to put it. I cannot put it in either one. So I change it into an equal. Now I know we already discussed how to present the interval notation here. And this is basically this. X in the interval -3 to 3. Any questions on this? Now let me draw your attention to one other thing. If I don't know how to convert this into this, I cannot solve it. There's nothing I can do to it. I can only convert it into what it equals to and then solve it. Okay. So now on the real line, I want you to understand that if this is -3 and this is 3, the solution of something like this is between those two, right here. This is where the solution is. Now, do we understand that this is not the same thing with that? What does this say? Careful. It says, find those numbers whose distance from 0 is 3. I'm going to put the equal symbol in there too. It's 3 or more. Not 3 or less, but 3 or more. So how do I write? I can solve it. I just have to write what it means. So what do I write that replaces this? One more time. 3 or more, not 3 or less.
-3 greater than.
So I have two options here, x and x. So I have to put an inequality symbol.
Greater than or equal to 3.
Very good.
Less than or equal to -3.
Awesome. So this indeed, we'll have in a moment, we'll write the solution, will be here as well as here. So this inequality cannot be presented as a compound inequality like this, a chain. That's not possible. It has to be translated into completely two separate inequalities. One that presents this territory, and the other one that presents this territory. We did not switch the inequality symbol. We just thought what that meant, and we came up with greater than 3, or, which is the union, less than -3.
But if it's greater than 3, that would be less than -3.
Very good. In a moment, I'll show you example. So this inequality has the solution, x in the interval -∞ to -3 with a bracket, union 3 to infinity. So this is or union. Okay. That was a very good question. So now let's try and check. If I pick -10, the absolute value of -10 is?
10.
And 10 is greater than or equal to 3? Very good. If I pick 5, the absolute value of 5. 5 is 5 greater than or equal to 3?
Yes.
Because the distance from between x and 0, the distance must be 3 units or more. 3 units or more. Is that clear? So now let's look at different examples. Before we do that, I'd like to look at a compound inequality, which is this one. And then we'll come up with examples. So I'd like to pick, for example, 58. Compound inequality. I want to refresh your memory on this. And -6 less than or equal to 1/2 x and -4 and less than -3. Okay. You see that these are two inequalities. Here's one, and here's the other. Very similar to, or not very similar, but exactly this. One inequality, and then this is another. Okay, so what will I get rid of first in order to solve for x? Right, this is the weakest link. I must clear this first. So I'm going to add 4 to all 3 sides. On the left-hand side, I get
-2.
very good. In the middle, I get 1/2 x. And on the right-hand side, I get very good. Now I have to get rid of one more thing, and I'm done. And I solve for x. What am I getting rid of now? And what do I need to do in order to get rid of that? Awesome. Multiply everything by 2. So -4 less than or equal to? Very good. Less than 2. And this is the interval notation. I don't have to do anything to it. I just have to say x is found in this interval. All solutions, x, are found in this interval. Now I would like to choose absolute value inequalities. So let's start with number 80. Any questions? Don't let me move on if you have. Yes, please, please.
How do you know to multiply by 2?
Because I want to clear 1/2. I want to solve for x, so this has to be, has to go away.
It was like 1/4, did you multiply by 4?
Yes, because that's how I get the 1. It's the multiplicative inverse. 1/2 times 2/1 will be 1. If I have 3 halves, I'll multiply by 2/3. If I have 7/5, I'll multiply by 5/7. Very good. Good, so let's look at 80. On page 203. Where are you? 80. 5 times 2x plus 1 in absolute value. And then minus 3 greater than or equal to 9. Okay. This is what type of inequality? Perfect. Once you read it, you know it comes. Okay, very good. So is it completely cleaned up or simplified? No. What do I have to do very first step? Very good. The weakest link has to go. Good. What will be the next step? Very good. Now it's completely cleaned up. And now I'm going to ask myself which type it is, because there are two different types. What are those types? One is in between, and I have to write a chain of inequalities. And the other one is outside, when I have to write two different inequalities, completely separate, and the solution has to have the union. Which one is it? The one with the inside or the one with the outside? How do I know? I have to read it. Okay. I'm asked to find these numbers, whatever they are, whose distance from 0 is 12/5 or more. By simply reading it, it should click. It's the outside. Very good. Because I said greater than, right? I said 12/5 or more. So or more, it's clearly the outside. So then I have to write two separate inequalities. And make sure you give the two separate inequalities for the outside. You cannot include anything inside. That would be a mistake. So this number has to be,
Greater than or equal to 12/5.
and the same number must be,
Less than or equal to -12/5.
that's exactly what it means. Outside, to the right, far away, to the right of 12/5, and far away to the left of -12/5. Now, what type of inequalities are these? Remember, we cannot solve this. I don't know how. But if I change it into these two inequalities, I will be able to solve it. So,
You could have done that just by putting the less than, or just over on the other side, and putting 12/5.
very good, careful. We cannot accept any inequalities unless they have either this symbol or this symbol.
Oh, they can have the.
You cannot have this. Please do not make that mistake. It makes no sense, please.
How did you get greater than or equal to 12 after?
You mean here?
Yeah.
I added 3. Negative.
Okay.
-3 plus 3 is 0, and 9 plus 3 is 12. That's okay. So is that clear? This makes no sense. Because this will mean what? That x is, at the same time, greater than a negative number and greater than the positive number. And it will include the middle portion, which is the in-between. So that's why we cannot do that. So we can never have this or this. We can only have this or this. Very good question. Good. So what type of inequalities are these? Absolutely linear. So we have two options. We either eliminate the fractions from the 5 from the beginning, or remove one and perform the operations. Whatever you want me to do, I'll do it. So 2x plus 1 greater than or equal to 12/5. What do we want to do? Say it again.
Subtract the 1.
Subtract the 1. So 2x greater or equal to 12 divided by 5 minus 1. But now I have to change that 1 into 5/5, right? Or you find the least common denominator and you multiply the top by 5. So 12/5 minus 5/5 is, good, 7/5. And now final step, I need to get rid of.
2.
That's why we multiply by 1/2. So multiply both sides by 1/2. 2/1 times 1/2 is 1. That's what I want. And the right-hand side is greater than or equal to 7/10. So we just finished the first one. Now we have to go back and solve the second one. So 2x plus 1 less than or equal to -12/5, and 2x less than or equal to -12/5 minus 1. So -12/5 minus 5/5 is, do we agree so far? Anyone? Any questions? Yes, please.
Where do you get the 7 from?
12 minus 5.
12/5 minus 5/5. I cannot subtract or add fractions that don't have the
No,
same
That
denominator.
was I did the I multiplied by 5 first.
That's fine.
And then
So then you find the least common denominator, and then you change this into 12 minus 5, which is 7. Okay, so let's go back here for a second. So 12 over 5 minus 1. I find the least common denominator, which is 5. 5 times 5 was 5 is 1. 1 in the denominator times what is 5 is 5. So then I have 12 minus 5, which is 7 divided by 5. Is that better? Yes? Yes? Okay, very good. So is this clear then? Any questions? So back here, we approach this in the same way, negative 5 over 5. So this is 2x less than or equal to negative 17 over 5. We get rid of 2 again, multiplying both sides by 1/2. So we get x less than or equal to negative 17 over 10. This is good, but it's not good enough. We have to present the solution with a union in between. The one that has to sit on the left should be on the left. And the positive one should be on the right. So how do I write the solution?
X equals parentheses negative infinity, negative 17 over 10 bracket. And then you bracket 7 over 10, infinity parentheses.
This is a solution. As you see again, it's not a trivial problem. We had a lot of ins and outs, right? Any questions here? Any questions for me? Yes, please.
How did